Alright guys, in this video we're going to take a look at our last quadrilaterals. We've got kites and trapezoids coming right at you. So the first one we're going to look at is a kite. So let's talk about the definition of a kite. A kite is a shape with two sets of congruent sides but that are non-opposite sides, or two distinct pairs of congruent consecutive sides. And again, consecutive meaning that they're next to each other. So here we see QR and SR being congruent and PQ and SP being congruent, but those not being the same size. All right, and it makes, well, a kite shape. Now, a kite is a little bit unique. It doesn't have any parallel lines, and it has a lot of weird properties. And you're not going to be responsible for knowing all the properties, but I'll kind of point out which properties are really important here. So a kite has like half of all the properties. It's kind of strange, all right? So it's got perpendicular diagonals, okay? That's something that's true of rhombuses, right? And squares, obviously, because it's a rhombus. So it's true of rhombuses. But then if you take a look at the sides, they're not all equal. Okay, it has exactly one pair of opposite angles that are congruent. So notice angle S and angle Q are congruent. So it's got one pair of opposite angles that are congruent, whereas P and R are not congruent. Right? It has one diagonal bisects the angles. So the angles that aren't congruent, the other angles get bisected by PR. So kind of like a rhombus, but kind of not. And then if it's a kite, one diagonal bisects the other. And so then inside my kite, I've got these diagonals that are getting bisected. So one diagonal bisects both the other diagonal and also the opposite angle. So that's kind of a lot, right? So let me simplify this down. I would say that these three are probably the most important, and the most important out of these three would probably be that it has right angles. But basically, with kites, all we're going to ask you to do is solve for some angles. There's not a whole lot more we're going to ask from you, all right? So let's take a look at a problem or two, if the textbook has one or two here, I believe. If I can get this to scroll down, it'd be really helpful. Yeah, so let's take a look at this problem here, okay? So I've got this kite. I know that BAE is 32. And I know that BCE is 62. So BAE, that guy right there, that's 32. And BCE, this guy right here, that's 62. Okay? And so the first one they asked for is CBE. CBE would be this angle up here. Well, remember, the diagonals are perpendicular, right? So that's going to be 90. Now, if that's 62 on the right side, inside this small triangle, the BCE triangle, I've got 62 and 90. If I subtract those from 180, I end up with 28 up here. Okay? The other angle they asked for is ABE, and that 28 is this guy here. Okay, so then the other one they're asking for, tell you what, let's cheat here. Well, just put that this way, make it real clear. All right, so that's 28. All right, ABE is going here. And once again, remember, this is 90. I'm just going to subtract this from 180. So 32 degrees, we end up with 180 minus 90 minus 32, and that comes out to 58 for this angle up here. All right, so that's one way. The other thing, if I was to jump down, say I wanted to get angles down in here, think of this as two congruent triangles. Let me kind of clean this up. Okay, think about this as two congruent triangles, and that's probably the easiest way to think about kites when solving for angles. There's a congruent triangle, there's a congruent triangle. And they have to be congruent by side, 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 right? I've got one side, another side, and then a reflexive side. So if you think about that as just being symmetrical and all the angles on the top match up with the ones on the bottom as long as you're folding it kind of lengthwise, that would probably be the easiest way to think about it when solving for angles in a kite. All right, so now let's look at the rhombus. Okay, so there's two different rhombuses, or not rhombuses, I'm sorry, trapezoids. So there's two different trapezoids we need to talk about. There's the regular trapezoid with at least one pair of parallel sides. Now, guys, we're not going to ask you any tricky questions about, like, is it exactly one or at least one? just generally know trapezoids have one set of parallel sides, okay? We're not going to try and trip you up on which definition of trapezoid you prefer. Now, the isosceles trapezoid is a special kind of trapezoid. It has equal sides, equal legs. So notice the bases are always the parallel line, even if they're vertical, okay? So don't get hung up on bases thinking that that means that they're always the top and bottom. Bases just mean they're the parallel lines. The other ones are the legs. So isosceles trapezoids have one set parallel, and then the other set, which would be your legs, would be congruent. So let's see our different theorems for trapezoids, and they're here. So there's 3 isosceles trapezoid theorems. The first one is that the base angles are congruent. So these angles would be congruent, and these would be congruent. The second is kind of the converse, so you really only need to worry about one, understanding one of these. It works both directions. And then also the original and the converse, when we combine them, is called biconditionals, if and only if. And what that means is that the diagonals are congruent. Okay, so if I have congruent diagonals in a trapezoid, then it's going to be an isosceles trapezoid. If I have an isosceles trapezoid, then the diagonals are congruent. So it works both ways. All right, so congruent diagonals. Now again, you have to be careful. Some of these properties are shared. So remember, a rectangle also has congruent diagonals. So don't just assume because it has congruent diagonals it's a rectangle, or vice versa, that it has to be a trapezoid. Okay. All right, let's keep it moving here. So let's look at maybe one problem here. A lot of this stuff, again, you're responsible for being able to solve angles and diagonals. So let's look at 2 here. So this first problem, I've got a railroad bridge. I know that AC is 13.2, so that's this distance right here. And then I know that BE is 8.4, so that's this distance right here. And they want us to find DE, which would be that section. Well, remember that AC is equal to DE, right? Diagonals are congruent in isosceles trapezoids. And then if this piece up here is 8.4, all I'm going to do is subtract 13.2 minus 8.4. All right? And that's going to come out to something like, what, 4.8? Is going to be that piece right there. All right, so that should be pretty simple. You should be able to solve any problems with diagonals. They should be pretty straightforward. And then with angles, okay, so you could have a couple of different setups with angles. Let's just talk, any trapezoid works this way, that the adjacent angles on one leg will always be supplementary. With an isosceles trapezoid, this works for both sets. 77 is going to match up over here, right? Because the base angles are congruent. And then these angles are supplementary, so I'm just going to do 180 minus 77. If I'm solving for angle R, like it says in the problem, I'm going to get 103 to go right there. All right? So again, trapezoids shouldn't be too difficult. Again, I can't show you every type of problem that you might run into. It's not about types of problem. It's about using the information you have and extrapolating from that and being able to build out. All right, so the last thing we need to talk about with trapezoids is the mid-segment theorem. Now, I'm not going to ask you to memorize it, you just need to be able to use it. The mid-segment theorem basically says this: if I go halfway down one side of a trapezoid, not even an isosceles trapezoid, any trapezoid, and halfway down the other side, that mid-segment, notice here the mid-segment's a nice little picture right here. Okay, that mid-segment is going to be the average of the top length and the bottom length. It makes sense, okay? It works exactly the way you think it might work. So let's look at one or two problems, and then we'll call it a day here. So the first one here, we've got these two lengths, 12.5, 10.3. I see that this is a mid-segment because it's bisecting both of my sides. So all I'm going to do is I'm just going to average my top, I'm just going to average these two together, and that's going to get me my answer. So I get 22.8 all over 2, and that comes out to 11.4, so it should just be halfway. All right, let's look at one last one. What if they don't give me the top and bottom? What if they only give me, the top and then the middle one? So notice this one, they've got it set up where I've got 8.3 and then they got 9.8, and then I'm looking for the final one. Well, there's really two ways to set this thing up. One way would be to average the top and the bottom, even though it's an x, and set that equal to 9.8. That'll get you there. Or here's another way. How did I get to the mid-segment? I added 1.5, right? So if I just add another 1.5, that should get me there. And that's going to come out to 11.3. Okay, so you could also solve this for x if you don't feel comfortable with the other way. But again, mid-segments. Use your brains. You can solve these out. They're pretty simple, straightforward problems. There's going to be some that are a little bit trickier than others, but use the general principle that the top and the bottom averaged together equals the mid-segment length. So this wraps up really everything we have for quadrilaterals. It wraps up parallelograms, it wraps up trapezoids, it wraps up kites. You do want to spend time reviewing. This is usually one of the hardest tests we give in geometry, not necessarily in trigonometry, but people have the hardest time with quadrilateral tests because of all the information. So hopefully this is helpful. Feel free to reach out if you have any questions.